Hello learners, welcome again to today's lesson. My name is Teacher Alice and we are looking at the last chapter of Form 3 Chemistry, and that is chlorine and its compound. So in our previous lesson we introduced and we looked at several things. One, we looked at the preparation of chlorine. We also looked at the physical properties of chlorine gas. So today we are going to continue from there and we will look at the chemical properties of chlorine gas. So this is part 2 of the chapter, chemical properties of chlorine. Now, the chemical properties that we are going to look at in this lesson, we are going to answer this in form of questions, and we are going to look at each property or each chemical property with several questions that are asked in our exams. So the first chemical property is that of the reaction of chlorine with water. So how does chlorine react with water? So the first question asks, state and explain the observation made when chlorine is bubbled in water. So we have collected our chlorine in a gas jar. Then if we bubble this chlorine in water, what do we observe? One observation is that the pale yellow color of chlorine fades. So we said that chlorine gas is pale yellow. So when it is bubbled in water, the pale yellow color fades or seems to disappear. The second observation, remember observation is what you can see from an experiment, okay? So the second thing we see is that a yellow solution is being formed. So there are two observations. One, the pale yellow color of the chlorine disappears, then a yellow solution is formed. So we have to explain that. So where are these pale yellow solution being formed coming from? So we have chlorine dissolves, it first dissolves in water, then it reacts to form a yellow solution, and this solution is what we are calling chlorine water. Chlorine water is a mixture of two solutions. One, hydrochloric acid, and two, hypochlorous acid. So hypochlorous acid is what we also refers to chloric 1 acid. So when chlorine dissolves in water, it forms a solution that we call chlorine water. And we said, I repeat, chlorine water is a mixture of two solutions, that is hydrochloric acid and hypochlorous acid, or what we are referring to as chloric 1 acid. So meaning the pale yellow color of chlorine will disappear because chlorine now will react with water to give us hydrochloric acid and hypochlorous acid. So this solution of chlorine water is what gives the yellow color. So the solution is yellow due to formation of chlorine water. Okay, that is the first question. Let us look at the second question on the same. Chlorine water in a boiling tube inverted in a trough was exposed to sunlight for 2 hours. Using a well-labeled diagram, show and explain the observations made. So now we have collected our chlorine gas. Then we want to see what happens when we react chlorine gas with water in presence of UV light. So we are going to invert our gas jar containing chlorine gas in a trough containing water and then leave it for 2 hours. So what are the observations? So this is the diagram here. The observations we are going to make are, remember, we have said that chlorine dissolves in water to form two products. One, chloric 1 acid or the hypochlorous acid, and the hydrochloric acid. So what is going to happen is that the hypochlorous acid will decompose. It is an unstable acid or compound. It is unstable. So once it is exposed to sunlight, it is going to decompose. So it will decompose to give two products or to release two products. One is oxygen gas and also hydrochloric acid. So the chloric 1 acid decomposes and this only happens in presence of sunlight. That is why we are leaving it under the sun for 2 hours to allow the decomposition of hypochlorous acid to give hydrochloric acid and oxygen gas. So that is why we can see that in our gas jar, now we are going to have oxygen gas. It is a colorless gas. So this is the chemical equation. We have hypochlorous acid decomposing or dissociating to give us hydrochloric acid and oxygen gas. All right, so that is what happens when we leave chlorine water in presence of sunlight. Okay, the next question, question number 3, I think this is also something to do with chlorine water, but now involves the effect on litmus papers. So we are told to state and then we explain the observation made when chlorine gas is bubbled in a gas jar containing moist, underline the word moist or wet litmus paper. So meaning we can't use a dry litmus paper. So we have two wet or moist litmus papers. One is red and the other one is blue. So what happens when chlorine gas is bubbled in a gas jar containing these two moist litmus papers? So these are the observations we are going to find. So the blue litmus papers turns red. Remember, when chlorine reacts with water that is inside the moist litmus papers, it forms an unstable hypochlorous acid and hydrochloric acid. So this solution will it will be acidic. So it will turn the litmus papers to red. The blue litmus paper will turn to red, or it will change to red, while the red litmus paper will remain red. Okay, that is the property of acid. The litmus papers on an acidic solution. So it will turn to red, the blue one, while the red will remain red. Then after some time, the both litmus papers will be decolorized, or what we call bleaching. Okay, meaning there is a bleaching agent that is formed when we react chlorine with water. So first, the blue will turn to red, the red will remain red. Then after some time, they will be decolorized, or they will bleach. Explanation, we say chlorine reacts with water, that is the water that is in the moist litmus papers, to form hydrochloric acid and hypochlorous acid that turns blue litmus to red. This is the equation when chlorine gas, we have seen that, reacts with water to give us hydrochloric acid and chloric 1 acid. Then the unstable chloric 1 acid oxidizes the dye. So the dye is the colored litmus papers in our case, to colorless material. So it bleaches. So when it decomposes, it gives the oxygen to the dye, meaning it does what? It takes the color. So the colored dyes, that is the red litmus papers, will be oxidized. So meaning they will be bleached. So now we will be having hydrochloric acid, then a colorless dye. All right, so these are the two equations that you can use, either the first one or the second one. It will be explaining the same. So chloric 1 acid reacts with the colored dye to give us hydrochloric acid plus the dye containing oxygen. All right, then we have to note something down here. Chlorine does not bleach. That one is, so chlorine is not a bleaching agent. All right, and it cannot bleach. That's why it cannot bleach a dry litmus paper. But chloric 1 acid, that is formed when chlorine gas reacts with water, that is what is used in bleaching. So chloric 1 acid cannot be formed with absence of water. That is why we cannot use a dry litmus paper. So we use wet or moist litmus papers when we want to show that chlorine can form a compound that is a bleaching agent. So chlorine gas is not a bleaching agent, but it reacts with water to give us chloric 1 acid, or what we are calling hypochlorous acid, that bleaches the litmus papers. Good. So that is that is the reaction between water and chlorine gas. The second property is the reaction with metals. So how do metals react with chlorine, or how chlorine reacts with metals? So we have a question here. We are told to state and explain the observations made when a piece of magnesium ribbon is lowered in a gas jar containing chlorine gas. So when we have a burning magnesium ribbon, we introduce it in a gas jar containing chlorine gas. This is what we are going to observe. So first, magnesium ribbon continues to burn. This is with a very bright flame. Second, a white solid will be formed, or a white powder will be formed. Then a pale yellow color of chlorine gas fades, meaning magnesium will react with chlorine to form or to give a product that is what we have, the white solid. So the pale yellow color of chlorine is fading because chlorine that was in the gas jar is reacting with the burning magnesium ribbon. So magnesium reacts with chlorine to form a white solid of magnesium chloride. So when a metal reacts with chlorine, it simply gives the chloride of that metal. So this is the chemical reaction between magnesium and chlorine to give us magnesium chloride. We are also told to give the equation for the reaction between zinc and chlorine. So zinc also reacts with chlorine to give us zinc chloride. Okay, so those are the examples we are going to use to explain the reaction of metals, with chlorine. Okay, now we'll again look at the reaction of chlorine with nonmetals. And here we are going to consider the example of burning phosphorus. So a burning phosphorus was lowered in a gas jar containing chlorine gas. We are told to give the observations made. So what do we see? So phosphorus is a nonmetal. So when a burning phosphorus is introduced in a gas jar containing chlorine gas, one observation or one thing that we see is that phosphorus continues to burn, with dense white fumes being formed. So we are going to see it is not done. We should be very careful when carrying out this experiment because it could be dangerous. So a pale green color of chlorine gas fades. We are told to give two possible equations. So these are the equations between phosphorus and chlorine. So phosphorus reacts with chlorine to give two products. One is phosphorus 3 chloride and phosphorus 5 chloride. So those are the chemical equations, well balanced. Okay, then we are told state two reasons why the deflagrating spoon with why we use a deflagrating spoon with a lid or that is covered. So remember we have said it produces fumes. So the explanation here is chlorine first thing is poisonous. Okay, so we don't want to inhale the chlorine gas that we are reacting with chlorine, with phosphorus that is. So that's why we have to cover the deflagrating spoon. Second, the phosphorus 3 chloride and the phosphorus 5 chloride being produced are also poisonous. So we have to make sure that we do not expose them, and also to ensure that the reaction is not affected by air from the atmosphere. So we don't want to react our phosphorus with oxygen or any other gas in the air, but we want to specifically use chlorine that is in our gas jar. So we have to cover this experiment as we are carrying out to ensure that it does not get affected, or it does not simply react with what? With oxygen in the atmosphere. All right. We continue with the next question on the reaction of chlorine with nonmetals. Then this is D of the same question. After the reaction is complete, 2 centimeters cubed of distilled water were added. Remember, this is the reaction between phosphorus and chlorine gas to form phosphorus 3 chloride and phosphorus 5 chloride. So we add now distilled 2 centimeters of distilled water. So the solution formed was tested with both blue and red litmus paper. So what we just want to know is this solution that is formed acidic or basic. So using the blue and red litmus papers, we put them inside the solutions that we have just formed, the solution we have formed by adding 2 centimeters cubed to a mixture of phosphorus 5 and phosphorus 3 chloride. So the observation will be that the blue litmus paper will turn to red and the red litmus paper remains red, meaning the solution is acidic. All right. So the explanation goes this way. Phosphoric 5 chloride hydrolyze in water to phosphoric 5 acid, okay, and produces hydrogen chloride gas. All right. Both hydrogen chloride and phosphoric 5 acid are acidic. That's why our blue litmus paper is turning to what? To red. So it is due to the presence of both hydrogen chloride and phosphoric 5 acid. So this is the equation here. We have phosphoric 5 acid plus water to give us phosphoric 5 acid and hydrochloric acid that are both acidic, turning our blue litmus papers to red. So that marks the end of this lesson. and the end of part 2. See you in the next video.